Hello everyone, welcome back to my channel. I am L. Pranati Reddy from Sri Venkateshwara College of Engineering studying 3rd SEM CSE department. Today's subject is going to be Mathematics for Computer Science and Engineering. The topic is going to be Test of Significance of for means of two small samples. In statistical analysis, comparing the means of two small samples is a fundamental technique used to draw conclusions about populations. This test of significance help research determine whether observed differences between two groups are statistically meaningful or merely due to chance. As we delve into this topic, we'll explore the intricacies of conducting such tests. Introduction. Test of significance for means of two small samples, often referred to as the t-test, is a powerful statistical tool used to compare the averages of two groups. This test is particularly useful when working with smaller sample sizes, typically less than 30 per group. It allows researchers to determine whether the difference between the means of two groups is statistically significant or if it could be have occurred by chance. Step 1. Data collection. Gather data from two independent groups, ensuring random sampling. Step 2. Formulate hypothesis. State null alternative hypothesis about population means. Step 3. Choose significance level. Select an appropriate alpha level, typically 0.05 or 0.01. Step 4. Perform t-test. Calculate the t-statistic and compare it to the critical value. Interpret results. Draw conclusions based on the test, outcome and p-value. Assumptions for t-test. There are four assumptions. Before conducting a t-test for two small samples, it's crucial to ensure that certain assumptions are met to validate the test's result. Independence, normality, equal variance, random sampling. Independence. The samples must be independently drawn from their respective populations. This means that the selection of one sample should not influence the selection of other. Normality. The data in each group should be approximately normally distributed. For small samples, this assumption is particularly important as the central limit theorem may not apply. Equal variances. The variances of the two populations should be approximately equal. This assumption can be relaxed if using Welch's t-test, which is an adaptation for unequal variances. Random sampling. The samples should be randomly selected from the respective populations to ensure representation and minimize bias. Hypothesis testing is a critical component of the t-test for small samples. It provides a framework for making decisions about population parameters based on sample data. The process involves formulating two competing hypotheses, the null hypothesis H naught and the alternative hypothesis H1 or HA. Null hypothesis. The null hypothesis typically states that there is no significant difference between the means of two populations. It is often expressed as H naught, mu1 is equal to mu2, where mu1 and mu2 are the population means of two groups. Alternative hypothesis states that there is a significant difference between the means. It can be two-tailed or one-tailed, depending on research question. Decision making. Based on the test results, we either reject the null hypothesis in favor of the alternative or fail to reject the null hypothesis. The decision is made by comparing the calculated t-statistic to critical value. Test statistic and critical value. In t-test for two small samples, the test statistic and critical value play crucial roles in determining whether to reject the null hypothesis. The test statistic is a calculated value based on sample data. while the critical value is determined by the chosen significance level and degrees of freedom. 1. Calculate test statistic. Compute the t statistic using the formula that compares the difference in sample means to standard error of difference. Step number 2. Determine degrees of freedom. Calculate the degrees of freedom, which is typically n1 plus n2 minus 2 for independent simple tests, where n and n2 are sample sizes. Step 3. Find critical value. Use a t distribution table or calculate to find the critical value. Compare and decide. Compare the absolute value of the test statistic to critical value. Calculating the t statistic. Calculating the t statistic is a crucial step in performing a test of significance for means of two small samples. The statistic quantifies the difference between the two sample means in relation to the variation in data. The formula for the t statistic takes into account the means of both samples, their standard deviations, and sample sizes. Component t statistic description: the test statistic for comparing two means. Interpreting the results of a t-test for two small samples requires careful consideration of both statistical output and the practical implementations. The primary goal is to determine whether the observed difference between the two sample means is statistically significant or if it could have occurred by chance. Statistical significance: it is calculated if the calculated t statistic exceeds the critical value, or if p value is less than the chosen significance level, we reject the null hypothesis. Effect size: beyond statistical significance, consider the magnitude of the difference. Calculate Cohen's d or another effect size measure to understand. Confidence intervals: examine the confidence interval for the difference between means. Context consideration: always interpret results within the context of the study. P-value and decision rule. Step 1. Calculate p-value. Step 2. Set significant level. Step 3. Apply decision rule. And step 4. Interpret results. The p-value and decision rule are crucial components in hypothesis testing for the means of two small samples. They provide a standardized approach to making statistical decisions. Let's see an example problem. To illustrate the application of a t-test for two small samples, let's consider an example problem. Suppose a researcher wants to compare the effectiveness of two different teaching methods on students' test scores. They randomly assign 20 students to two groups of 10 each. Group A receiving traditional instruction and Group B receiving new interactive method. Group A, sample size N1 is equal to 10 mean score. 75 standard deviation, S1 is equal to 8. Group B, sample size N2 is equal to 10 mean score. 82 standard deviation. Hypothesis: mu1 is equal to mu2. No difference in mean scores. There is a difference in mean scores. Mu1 is not equal to mu2. Standard level is equal to 0.05. Limitations and considerations. While t-test for two small samples is a powerful statistical tool, it is important to be aware of its limitations and consider various factors when applying the interpreting the results. Understanding the aspects ensures a more nuanced and accurate analysis. Sample size sensitivity, outlier impact, assumptions violations, and context consideration. These are the limitations. Thank you.